1 minute, sir. Yeah, good morning. So welcome all the participants for the day 5, session 2. Now with us, Mr. Ram Prakash Valla, Director, Distant Productive Solutions Private Limited. Now, sir, as always with us, he is always taking our students to his industry. He's delivered more lecturers in our institution. He has given a lot of seminars, technical talks for our students. So he's very familiar face to us. And again, sir has given an opportunity for us to talk in the faculty development program. So sir has 25 years of overall experience in manufacturing industry. Graduated from Government BTT College of Engineering, Davangere in Mechanical Engineering in 1994. He is an executive MBA from Indian Institute of Management, Bangalore. Initial portion of his career was in Bharat Fridge Warner Limited, Bangalore, as a German machine tool manufacturing company in India. His areas of expertise are CNC machining, jigs and fixtures, robotics and automation, Toyota production system, and lean manufacturing. As a manager, international business, he has traveled extensively in India and abroad and worked closely with the industry for various manufacturing applications developments for various automotive and non-automotive components. He has traveled more than 35 countries to set up distributor networks to sell Indian CNC machines in Europe, Middle East, and Southeast Asia. Being founder and managing director of Distant Productive Solutions since September 2004, he is engaged in setting up of an ISO 9001-2008 and ISO 14000 certified manufacturing organizations, which is engaged in manufacturing precision components for Rexroth Bosch, Entries International USA, and Bitzer Corporation Canada, Pramco, SRL, Italy, etc. Is state-of-the-art CNC machines and robotic systems. Distinct Productive Solutions are also involved in design development of automation solutions and successfully implemented Industry 4.0 systems in manufacturing of plug shells. Company operates with 55 CNC machines, 2 die casting machines, and 2 locations in Bangalore and Hosur, and 125 people and 30 crores turnover. He has awarded a best supplier in 2014 for the outstanding performance in quality, cost, and delivery by the Bosch Rexroth. He was awarded as Ujjwala Udyami by Karnataka Small Industries Association during 2017. He was awarded with the SME Productivity Championship Award from the Indian Machine Tool Manufacturing Association during the August 2018 in a national level productivity event called National Productivity Summit held in Chennai. His efforts to modernize the manufacturing plant was given a financial aid of 15 lakh by the Government of India, Ministry of Heavy Industries during September 2018. So, with us, a great industrial expert to share his valuable information with us and in a faculty development program, ACT sponsored online faculty development program. Welcome you, sir, and over to you, sir.
Yeah, thank you. So, thank you very much, Dr. Satish, sir, Dr. Karthikeyan, sir, and thank you all the participants gathered in the virtual platform. Am I audible?
Yes, sir, you're audible, sir.
Yeah. So, thank you for inviting me to express my thoughts about Industry 4.0 for manufacturing industry in this 5-day FDP program. And I've been associated with the RRC for last 7 years in as far as our capabilities are concerned. I believe in participating and dissipating knowledge to the students and the younger generations. And in that context, RRC has been inviting us regularly for delivering lectures and being a part of their internship programs and things like that. Uh, so I'm very happy to be in this part of this FDP program. So let me just, this is going to be the agenda. So this is going to be the flow of my talk. I'll start with a small introduction, and of course you have heard a lot about lean in the last 5 days. So, but still I will tell my perspective of lean and what I have practiced and what I have seen as lean from my point of view. And I'll also touch upon Industry 4.0 and its building blocks and a nature of an ideal Industry 4.0 scenario. Like, there is a lot of myth, there is a lot of misconception. Wherever internet is there, wherever computer is there, people tend to call it as a Industry 4.0 system, but it is not so. It has to pass through certain criteria. So I'm going to talk about FIC architecture, which talks about all the essentials of an Industry 4.0 scenario. And then I'm going to narrate at least about 3 examples of Industry 4.0 implementations, out of which two are uh, the ones which have happened in our factory. Of course, they are small, but they are quite effective. And there is one which is a Fanuc Robo factory in Japan, which is a completely autonomous factory. It's something called smart factory. How robots manufacture the robots. That video we will see, which will talk about, which will cover many aspects of Industry 4.0. Then we will talk about similarities and differences between Lean and Industry 4.0. I'm just trying to connect how Lean is going to take forward a different shape with the help of Industry 4.0 in the days to come. And Industry 4.0, is it a future of Lean? We are going to debate on this a little bit. Then we will draw conclusions, and I'll be open for questions at the end of the session. Well, just after I logged in, I was talking to Dr. Karthikeyan, and the very subject what is chosen for this FTP, that is lean manufacturing in the Industry 4.0 scenario. It is a very apt subject in the present day scenario, because after practicing about 25 years in the industry, almost practicing so many lean practices, I find that the lean practices have a lot of advantages, but they do suffer from some closed looping issues. Many of the lean practices can be implemented effectively to the extent of 80-90%, but there is some small closed looping not being possible. So the Industry 4.0 possibilities are making this shortfall of lean practices uh, and make it 100% effective. This is what is our realization. uh, so this subject is a really a good topic, very thought provoking, and I'm sure that the participants had a very good insights during last 4 or 5 days of continuous the lectures and the views from different researchers. And I'll try to I don't know what others spoke, but I feel that many points, many aspects would have been covered by all the scholars in the past. But still, I'll try to put my point of views in this next about 40-45 minutes. And I hope that this will give some insights, some good insights to the participants. So with that as the opening note, I would like to see the present day scenario. Now the customers are very demanding. they want the improved quality, they want the reduced cost, and they want at much faster rate, at a very reduced lead time. So this being the situation, so that means everybody wants better, everybody wants cheaper, and everybody wants faster. So better, faster, and cheaper is the mantra. This is what is required by the industry: the better, the cheaper, and the faster. So that's where these concepts came into picture. So this is a lean originated by a tussle between the Ford and the Japanese. The Ford said that I can give you comfort at a higher cost, but the Japanese manufacturer said that the comforts at the same cost. So that's something where the lean concepts originated. That's where they said that we can. So Americans said that I can give either this or that, but the Japanese said we will give this plus that. So both we will give, the comfort as well as the cost effectivity. Both we will give, whereas the Western manufacturer said we will give either comfort or cost. So that was the difference. So that was possible by the lean principles at that point of time when the lean originated. So we see several definitions of lean. I have listed some here. So it's predominantly about eliminating the waste. It's predominantly about economic and time efficient use of factors of the production. Lean is a permanent struggle to flow value to the customer. The core idea of lean is to maximize customer value by minimizing the waste. These are all the different definitions of lean, what we come across in our textbooks or Wikipedias or Googles or anywhere. So lean is a set of, basically what I believe is lean is a set of management practices based on Toyota production system. What Toyota production system initiated, that is a set of management principles. So production management principles are the actually the set of these principles are actually lean. But above all these definitions, for us, lean manufacturing is a way of life. It's a culture, because lean doesn't stop within the organization. Lean is required from with the suppliers, within the organization, with the customers, and even with the transportation, in the supply chain, everywhere lean is required. So it cannot be confined to a one production system. It cannot be confined to one set of people. It cannot be confined to some set of books. It has to be it is a way of life. It is a culture. It is a culture to be followed by the industry across the supply chain. That is what, only then it becomes effective, only then it becomes profitable. The real benefits of lean can be uh, reaped. Okay, having said that, what is lean, now we will talk about what is industry 4.0. So Industry 4.0, of course, this is something what you would have seen in the past 4 or 5 days by many other speakers. But this particular representation is derived by me out of my own, uh, intuition of how this would have grown. So basically, the first revolution had only the mechanical systems, and it is called mechanization. And the second revolution, it's electricals and electronics got embedded into the mechanical systems. Then it became electrification. So we can call the second revolution as the electrification. And the automations sat over electricals and the mechanical assemblies, and that becomes the third revolution called automation. We can call it as the automation. And the fourth is on the mechanical systems and the electrical and electronic systems, the automations, above all, the IT systems, the cyber physical systems, they got embedded into all these four, and to make the entire system more effective, and it can be named as digitalization. So for us, the first revolution was mechanization, and the second revolution was electrification, the third revolution is automation, and fourth revolution as digitalization. So this is what is called as basically the digital transformation. And this is what the industry calls as Industry 4.0. So basically, it is a digital transformation. The digital transformation touched the human lives much earlier than industry. So in 2011 onwards, it is treated as Industry 4.0, whereas the digital transformation touched the human lives much earlier. So we got internet, we got the mobiles, we got so many other things. People generally confuse with, uh, even easy bank transfers and these easy mobile applications as Industry 4.0. It is not. The internet industry, by making the industrial elements enabled by internet, that is the start of Industry 4.0. Okay, so digitalization started much earlier than the Industry 4.0, the industrial revolution. All are able to hear me?
Yes, sir.
Yeah, okay. So, yeah, basically these are the, there are so many techniques, so many, building blocks of Industry 4.0, but I'll limit my talk only to name them. I will not get into the details. And my focus would be here to, promote, to make you aware of a fundamental of the Industry 4.0. That is, what is the fundamental nature of a matured Industry 4.0 system is my focus here. So we can talk hours together, we can talk days together about each of these technologies, but that is not warranted unless we understand the fundas of Industry 4.0 and fundas of a basic, matured Industry 4.0 situation. So these are, there are these tools are, some are virtual in nature, some are physical in nature, some are management in nature. So this is how they are, what I should say, they are categorized. Okay. So this is something I'm talking about the nature or the characteristic of a matured Industry 4.0 system. So as I said in my opening remarks, there is lot of confusion among the industry sectors and academic sectors, say what is the ideal Industry 4.0 situation. Anything which is connected to internet, people tend to tell that this is a very good Industry 4.0 system, which may not be true also. If you connect an element of a machine and with the internet, if you enable it with the internet, and if you start getting some information out of that equipment, uh, it cannot be called as an Internet of Things, or it cannot be called as an Industry 4.0 situation. So basically, an ideal Industry 4.0 situation, a system has to pass through these these five steps. That is, the first step is called the connection level. So if you imagine a machine shop with the CNC machines, so elements of the machines have to get connected with this with internet. That is the first step. That is called the connection layer. That is That is where we are making the machines or the machine elements or the manufacturing elements enabled for internet. We are giving a life. We are giving, not life, I would say. We are giving an intelligence. We are enabling it to talk, okay, by giving an internet enabled sensors. That is first is the connection layer. By connecting it, it will be able to monitor itself. Self-monitoring feature will be acquired by enabling a machine or a manufacturing equipment, by enabling it with the internet. That is the first layer. That is the first step of the internet of the industry 4.0 scenario. The next layer is conversion. That is, as the machines start working, they are supposed to work at a particular parameter. They are supposed to work at a particular speed. They are supposed to finish the work at a particular time. So these are the parameters. If they work at a particular parameter, then that is supposed to be working healthy. It is as good as our human health vitals. We should have so much BP, we should have so much sugar, that content should be so much. These are the vitals basically. Okay. So when the manufacturing machine or the manufacturing device is able to be aware that able to be aware of its own performance, its own vitals, that is the second stage. That is called self-aware stage. So by connecting the machine with the internet, we are only reaching the first stage, that it is able to monitor itself, it is able to sense itself. And the next stage is that it is able to be aware that, yes, I am working, I am not working, I am under breakdown, I am under overrun, I am under maintenance, my some elements temperature is going up, going down. So it is able to be aware of its own performance or its own working. That is the second stage of industry 4.0. Then it takes to the third layer, that is called the cyber layer. That is a very interesting thing. So here, what happens, the moment a manufacturing device is enabled with the internet, and it is able to uh, aware of its own working, its own vitals. So imagine there are a fleet of such machines, and they are placed in the multi locations. They are all these are all get converted into a data basically. Now the machine has its name, its number, its capability, everything physically is there. Physically it is there on the shop floor. Then that is through internet, that only that information goes up to the next layer. So then its vitals, they go up and sit in the cyber. So eventually this forms a virtual layer of the entire machine. And when it is done for the entire machine shop, it will create a virtual layer of the entire machine shop. And when it is done for a machine shops of multi-location, it forms multiple virtual layers of entire machine shops in different locations. So you should be able to get a feel of a virtual data layer of the physical machine shop. Okay. So that's, hello.
Yes, sir. Audible, sir.
Yeah, I think there was some disturbance.
Yes,
Okay.
sir.
So yeah, so basically that is what is called as the cyber physical system. So you have multiple layers of the multiple virtual layers of the machines and machining elements and the machine shops at the different geographical locations. So that is what is called the cyber physical system, the virtual virtual layer of the physical system is being possible to develop by the connection and the conversion layer. That is nothing but big data. See, imagine there are hundreds of machines in multiple locations, and all that machines are connected with the Internet of Things, and then that is able to monitor its own performance, its own vitals, and everything is going in sitting in the cyber, and that is nothing but cyber physical system. So because at that stage we have the data, every physical system is converted into a data. So, and that is nothing but big data. So that is able to compare the performance of one machine with the other at the virtual level, and one machine shop with the other machine shop at the virtual level, and one element with the other element. So it is able to self-compare. So we have come to the third stage. That is, the initial stage is self-monitoring, the second stage is self-aware, and the third stage is self-compare. And once a lot of comparisons are there at the cyber-physical system, then comes the cognitive level, the cognitive layer. The cognitive means cognate means is the intelligent layer. It is intelligence. So that is where data analytics, because by now we have a lot of data collected about the machine shop, about the machines, about the machine elements, about their performances, about their vitals, about the different locations. So many informations are available, which is ready to compare and ready to analyze and ready to subject it to a decision trees. So that is what happens in the cognitive layer. That is data analytics, the artificial intelligence, and the decision trees, and all these things will take the self decisions that yes, this particular vital is going above the specification, the specified limits, or this vital is not as per the historical data, or this vital is not as per the standards of whatever the American standards or the ISO standards or IS standards. So some specified vitals are there, like typically like your health report. There will be a reference range. The BP has to be within 120/80 or whatever. So some references are there. Like that, all these, the cognitions are built into the cognitive layer through data analytics, artificial intelligence, and the decision trees. And then the system is able to decide what is good for this and what is not good for the manufacturing system. So that is the fourth layer of Industry 4.0 maturity. And the last and the final layer is called configuration layer. So having monitored the device, then making it self-aware, then compare with many such similar devices, then decide what is good for me, what is good for my performance, my machine, and all that. Having decided, then in the last stage, it is about taking actions. Finally, if we know everything and if we don't take actions, it is of no use. So finally, it is about the taking the actions. So that is something called self-configuration layer. So that's a very important layer. So that is where the decision of derived in the cognitive layer, the decision which is supported by comparing similar such many machines or machine shops in the cyber layer, which is again derived by the self-awareness of the machines itself, which is again collected by the basic machine elements. So the machine elements are now empowered to take a decision of its own for its better performance. So it passes through a very beautiful mechanism of self-monitoring, self-aware, self-compare, and self-decide, and self-configure. So the system, any system which is able to self-configure itself, without the intervention of the human being is called a ultimate, a very, very, very matured industry 4.0 situation. Okay. And very different manufacturing setups are in different levels of maturity. Some are at the self-monitoring level, some are at the self-aware, some are at the self-comparative level, and some are at the self-decision level, and many are at the self-decision level, where the final decisions are taken by the human beings even now. But there are few cases. I will show you one factory of Japan, Fanuc, wherein even those decisions are taken by the machines itself. It's completely, manless, lights off factory kind of situation. So this is a very, all of us, we have to, in fact, this is worth storing this particular slide or this particular information, because this is the basic, very, very basic of a matured industry 4.0. This is called 5C architecture. So any industry 4.0 system, whoever the implementers or the researchers, they have to pass through these 5 steps when implementing or when researching or when designing an industry 4.0 scenario situation. Okay, so going ahead, this is just in support of my previous slide. Suppose all of us don't talk to each other, then can we expect a good results? It is not possible, because intercommunication is very much required. So that is where these are the machine elements. That could be a hydraulic cylinder, it could be a ball screw, it could be a power pack, it could be anything, any of these. So these are basic elements of all the CNC machines. So now when we connect everything through the internet, this is the first layer wherein the elements are able to speak. Okay, elements are able to speak to each other. So then this is what I was talking about. We have the machine shop. Then we should have a virtual layer of the machine shop. At the end of the stage 2, we should have a virtual layer that is completely filled with data, whether it is wanted or not wanted. But the system will collect a lot of data. Okay, because we have empowered the elements of the machines to collect these data. So that is nothing but big data, because a lot of data is collected. It collects in a very, very interesting way. Every second multiple data are collected about its performance, about idle time, about rejection, about so many things. It will keep collecting, and it creates a virtual print. This is basically a virtual print. That virtual print means it is only will have complete data. With this data, we should be able to visualize how is the factory, how factory is running. That's the purpose. So that's the second stage. It is nothing but big data. Then comes your analytics. So in analytics, it will do the comparisons, and the decision trees are derived based on these analytics. Very beautiful tools are available for data analytics. So all these things are done. So when it comes to manufacturing, so many of you will be aware that there are various sections in manufacturing. There is a production, there is rejection, there is process consistency, there is gauge capability, there is machine capability, there is power consumption, there is about maintenance, MTBFs, MTTR, and all that. So every area of manufacturing can be brought under the industry 4.0's. We have to enable every activity to be captured by the sensors. Basically, currently I'm sure people are doing all these by manual methods, writing on the production books, writing on the rejection papers, and the gauge capabilities recorded in some Excels and stuff like that. The maintenances are all, manual and, people driven. Most of us do the breakdown maintenance. There is nothing, people don't follow the preventive maintenance methods and things like that. So these are all basically the, every aspect of it is coupled with some or other lean principle, OEE, the overall equipment efficiency, the PPM, and the CPCPK, the statistical methods of checking the process capabilities, the CGCGK, the gauge capabilities of checking the capability of the gauge, the machine performance capabilities, CMCMKs, machine MTBF, MTTR, mean time between failures and mean time to repair. These are all the various parameters defined by some or other lean principles to monitor the performance of a different activity of a machine shop, right? So our objective, the industry 4.0's objective should be, the system should be able to generate or to collect all the data that is required to calculate OEE, for example. It should be able to collect all the data that is required to calculate PPM. It should collect all the data that is required to calculate CPCPK across the machine, first on the machine, then across the machine shop, then across the machine shops in different locations, and everything should be having a cloud connectivity so that it forms a virtual layer. Then the analytics, it is far more guided in case of manufacturing, because the principles are already derived. The CPCPKs are well established, OEs are well established in the industry, PPM, everybody know about PPM. So basically, whatever is derived over years have to be strengthened by the data collection electronically and evaluation electronically and the actions in the autonomous mode. That is what is the requirement or the hope that is there from the industry 4.0 scenario. So let me just take you through one simple example of a matured industry 4.0 situation which we have implemented in our manufacturing setup. Let's imagine, I hope everybody are familiar with a turning process, component machining by using a CNC turning machine. So let's say we have to turn a component. It has a particular dimension to be achieved after machining. So when we do this, after the machining is over, the part has to be measured either by a gauge or by an instrument. So that is done by a person, an operator who will check this, and there is a reading errors. So if any error is there, then there is a person's involvement is there. Okay. Then the next stage is that he has to calculate whether the measured reading is above the tolerance limit or below the tolerance limit or in the mean limit. So if at all it is above the tolerance limit, he has to do a correction. So this mental calculation he has to do, whether to give 5 micron offset or 10 micron offset or 20 micron offset, depending on the offset he has to do. Then there is again a manual operator involvement. Then comes the correction. We have to typically give an offset correction for the CNC machine, depending on the size what we achieved. Suppose it is less, we have to add say 5 microns, 8 micron in the offset value, and then the next component will come within the tolerance limit. So feeding this error, offset correction, is again by the operator or a programmer. So here in a simple manufacturing cycle, you see so much of manual intervention. A person has to measure it, and a person has to analyze it, and a person has to estimate the error, then he has to feed it to the machine and then get a correct component. Correct? So this is a predominantly an open loop system, right? Now, so what we have done is we have made an auto gauging station, auto measurement station, which will measure the component automatically. Yes, of course, the component has to be placed on the gauge by a person. Okay, or if it is a robotic system, the robotic system can place it onto the gauging stations. Once it is done, then the auto analysis, because the data is read by the system, it is not by a person. So the calculation is done by our cognitive system, the device, which will see, it will compare with the upper and the lower reading, and then it will do an auto correction. It will estimate the reading, how much offset has to be given. Then it automatically, if at all it is tending to go out of the specified limits, it will do the correction by itself. So it is closed looping. So there you don't see any manual intervention. Okay, so this is called closed loop system based quality. So the earlier one, what you saw was a operator based quality, and here what you see is a system based quality. It is all about closed looping. The industry 4.0 talks only about closed looping. Okay, there cannot be anything which is open loop, is the concept. So this is just the photograph of the system. There's a CNC machine. There is an electronic gauge. There is a inspection results which are displayed onto this HMI screen. So this is an auto correction mechanism. So this is what actually happens here. Suppose my tolerance is 37.37 to whatever this range. So for each reading, so this is the upper limit. The green lines, what you see is the upper and the lower limits, lower control limit and upper control limit. And green, what you see is the mean. So the machine shop's objective is to produce the component in the mean value all the time. Okay, but as a law of nature, it is not possible. There are no two identical parts. No two parts can be produced identically. So it tends to produce different dimensions, but within the same tolerance. Now, the system is able to calculate each and every component and see whether it is able to see, self-aware. It is becoming self-aware of its own performance, which is what I was telling, the stage 2 in the industry 4.0 scenario. Okay, so where it is able to understand that yes, my tolerance is going out of yellow line, going out of upper control limit, then the system itself triggers a process correction, and it does the process correction, and it brings it back to the mean, so that the next several components produced are within the quality, within the specified limits. So if you see this system here, it's a very simple system, but it has a self-monitoring capability. It has a self-aware capability. It has a self-comparison capability. It can decide what is good for it and what is not good for it, and it can self-configure. Everything happens without the intervention of any human being. And this is a very, very live system, what is running in our factory. And we are able to reach zero defect situation on that particular parameter after implementation of this industry 4.0 situation. Okay, now moving on to the second second scenario. We have a cloud-based manufacturing system. I think this is here we have Andon. Andon is a very, very famous concept of lean, wherein it will show you the whether the machines are working at any point of time or not. So this is the green means the machine is working, the red means the machine is not working. So we have the dashboards, we have the analytics, and we have many other things which are able to monitor it live. Okay, so we have done a great amount of analytics here. Yeah, see here, you can go to the live data. I will not go to that now because lack of time. So here, basically, I'll just touch upon a few aspects. See, here there is a analytics called demography. Okay, so this is nothing but the machine shop's demography. So these are all the different machines which are working in my factory. These are the till yesterday's performance as of yesterday. See, okay, interestingly, we have given names to all the machines like this, Hara, Hari, and all these, in the mythological names we have given. That is, instead of just calling them as machine 1, machine 2, machine 3, we have called them with some names. Okay, so now in this machine, so now as a management person, when I just see in this, when I go through this, I have 20 machines here. Out of that 20 machines, only 6-7 machines have worked in the acceptable limits. All others have not worked on the acceptable limits. I will be able to go into the details of this. What is the what has happened in the yesterday, like some machines, what was its percentage, how much it worked, and what was the performance in the shift 1, what was the performance in the shift 2, and what way we are going away from the targets, right? So these are the basic analysis it is able to give out. So we will also be able to know what are the idle times on the shift 1. The no operator was because of no operator, we have lost in this month about 3,900 and odd minutes. In the last shift, we have lost about, the machine cleaning was 41 minutes, and this is something, is the analytics. Hello, you are able to hear me?
Yes, sir. It's audible, sir.
Okay. So this is just basically here what is happening is this is demography means we even without entering the shop floor, I am able to know. In fact, I have not gone to my shop floor, but I know what is actually happening in my shop floor, what actually happened yesterday, what actually happened in the previous so many days, we will come to know by these kind of analytics. This is typically a great analytic thing. So here we also can see individual operators performance. Okay, so this is the performance of this particular operator, at what time he logged in and what time he logged out, and what is the target and how much he achieved, what was his idle time, how much he rejected on that particular day. Like that, the entire data is coming out of this system. This is basically called my machine, which is monitors machine shop, which can monitor machines, which can monitor operator performance, which can give rejection reasons, which can give the idle time reasons, which can give the OEE and things like that. So this is something what we have developed, and which is running very, very successful in our factory. Well, so now let's compare. Let's compare this system. You're able to see my screen?
Yes, sir.
Okay. So let's compare the machine monitoring system with reference to my 5C architecture. Okay, making some sense. So it has a connection. It is able to self-aware. It is able to self-compare. It is able to self-decide also, because it is able to show you what is the OEE, what is the rejection percentage, what is the idle time, what is the everything it is able to tell, but it is not able to self-configure. So
ஜோதி அவர்
our
மேல வந்துட்டு இருக்கிறோமா மேல வந்துட்டு இருக்குங்கண்ணா
hello.
Sir, please
So,
continue, sir. Sorry for the
yeah,
disturbance.
yeah.
Participants,
So-
don't unmute yourself, please.
So basically, this is not self-configurable system, but up to, I think, in the scale of 1 to 5, that is 1 being connection and 5 being configuration. Maybe I can rate it as 3.5. It is somewhere in the mid of cognition layer. So it is not so matured 5C architecture where there is a lot of scope to improve and go further. So that is the thing. So now I'll just show you, out of academic interest, I'll show you some video. You're able to see the video?
Yes, sir. Is visible.
Yeah. So here you can see, you cannot see any human being in this factory. Okay. So the entire, this is basically the Fanuc factory in Japan, which makes the robots. The robots are making the robots here. So what you see here is the robots are manufacturing robots, and you don't see any person, because see, you can imagine now here the amount of the automations, the amount of self-aware, the self-configure, self-decision, and the self-awareness and self-configurable systems adopted in this factory. Okay, so this is something really smart factory, wherein a very, 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 very high-end smart factory, which is probably I think the state of the art, and which nowhere comparable to any of our maybe we may need another 30-40 years to reach this kind of maturity in our so even painting, these are kind of difficult to do by people. So these kind of operations are all handled by the robots. The welding robots. See here, the CNC vertical machining center is being assembled by the robots. Well, I'll skip this. We'll take it forward. So basically, this is a very, very ideal. It scores full marks in the 5C architecture because it is able to pass through all the all the levels of all 5 C's it is able to pass. Okay, now having seen these 3 examples, and I just wanted to conclude with few remarks. So now some questions may be coming to the participants after seeing last 4 days sessions. Are lean and industry separate, or are they conflicting to each other? Or is Industry 4.0 is a subset of lean, or whether lean is a subset of Industry 4.0, or is there anything common between these two? So yes, there are commonalities and there are differences. So, lean and industry similarities are like both needs full attention of the management, and PDCA, that is plan, do, check and act, is a very, very important. So activity cannot be outsourced. It has to be done within ourselves, within the factory. And the successful implementation of lean or Industry 4.0, both can lead to substantial benefits to the organization. Whereas the difference is the lean focuses on the people motivation is very important, whereas Industry 4.0 focuses on the computer, automation, robots. Okay. And lean is often easy to fix the problems. The tools are very easy, very interesting. The Kaizens, the Kanbans, the Andons, and so on. Whereas complex hardwares and softwares are involved, which is not easy to solve in Industry 4.0 scenario. The flexibility in changing productive system, and it is, whereas Industry 4.0 is quite not very flexible. Okay. And the last, the lean can work without computers. Okay. It is not mandatory that computer is required for a lean system, whereas the computer and the hardware is a must. Without that, the Industry 4.0 doesn't work. Okay. Then I'm running out of time. I'll finish in next 2 minutes. So the future of lean and Industry 4.0. See, so far the industry has seen a very, very matured levels of lean implementation. It's a long journey we had as far as the lean is concerned. But today we are on the crossroads because many concepts of lean are not able to close loop the systems because they are not empowered by the electronic or the sensing systems. So we are not able to close loop many of the systems. So that is where Industry 4.0 comes as a complement, as a complementary feature to the lean technique. And it is going to be called as Lean Industry 4.0 in the future, because the lean and the Industry 4.0 has to go hand in hand. They have to go together. So that is going to be the future. So people, the companies, the industries which are already practicing lean have to migrate, have to elevate themselves with the Industry 4.0 principles and embed them with the lean concepts to arrive at the lean Industry 4.0 to maximize the benefits. So lean alone cannot help. Industry 4.0 alone cannot help. So together they have to coexist. So concluding remarks. So digital transformation is treated as the fourth industrial revolution. Digital technology is only an enabler. The transformation is important to retain the competitiveness. The lean practices standardized using PDCA. PDCA means plan, do, check and act are the basis for Industry 4.0 implementation and the success. Without PDCA, we should not attempt to implement Industry 4.0. Industry 4.0 concepts, enablers can enhance the benefits of the lean concepts. It's all about closed looping. Many activities that were not possible in the past, in the pre-digitalization era. So lean and Industry 4.0 should complement each other and coexist for better results. Ultimately, the tools, concepts, technologies can help to attain operational excellence, but the people and the creative leadership, that is the one which makes it possible. Unless people see, these are the tools which are helping us to do better. We cannot say that I have implemented lean and it should give me results. No, the people behind that are very important in making it to happen. And the last but not the least, before I end, we have to start these things small, but we have to think it very big, and we have to learn very quick, because the time is going fast. Digital era is going very fast, and we have to move fast for the successful implementation. Thank you very much. So with this, I hope I made some sense to the listeners, and I'm open to answer any of your questions.
Now, dear participants, now you can unmute yourself to ask questions for the speaker. Yes. Any question?
Hello.
Yeah, please.
Yeah, good afternoon, sir. It's a very good session that we had a very real-time view of the Industry 4.0.
Okay,
And now
thank you.
my question will be for the speaker is like how we can change the industrial setup or scenario regarding the different manufacturing things that is coming up. Like for example, the EV is in boom currently right now, and
Yeah,
every industry is facing a challenge in changing their setups to the traditional ones to the EV.
yes.
So how, like, what will be your opinion in this regard? How they can go ahead in that, or how the
Yeah.
Industry 4.0 will help them?
Correct. Yeah. See, there are two ways of looking at it. The one great thing about EV is that all the EV equipments are coming as internet enabled. If you see an ether vehicle, or if you see any any electric vehicle, they're all coming with the electric with the internet enabled things. Okay. Now the question comes, what happens to the manufacturing system which are going to produce the parts of, or produce the elements of these EV vehicles or EV systems? Well, that's a very interesting thing, because in any EV vehicle, the engine part is removed, whereas all other elements are still remaining. The transmissions are there, the steering systems are there, and all that. So basically, the manufacturing system which were producing these elements will continue to be in the same situation. So there may be some legacy machines which are producing some parts. There may be some very latest CNC machine which are producing parts. Some are already internet enabled, some are not enabled, some are not possible to enable, some are with the very old RS-232 port, which is difficult to enable, and things like that. That's one of the very biggest challenges what Industry 4.0 is facing as well. So every system, however old it is, if it is electrically connected, it can be made it can be made IoT enabled. That is one fundamental thing what today's sensors have made it possible. So because of the huge advancements what happened in the sensors today, if you want to measure anything, the sensors are available. You want to measure temperature, you want to measure vibration, you want to measure mist, you want to measure pollution, you want to measure mist, anything, you tell anything, the sensors are available. That is the amount of advancement what has happened in the sensor industry, the electronic sensor industry. So that makes our connection layer very strong. The basic challenge is in the connection layer. Then subsequent to that, the moment the connection is done, then anything and everything can be taken further to the next layers of conversion, then cyber, then then cognitive and configuration. So that way, yes, with the advent of embedded sensors or the electronic sensors, these challenges can be handled in a much bigger way. But nevertheless, this is a very big research topic and a research area. It is going to be an evergreen research area to link lean with the Industry 4.0 in the days to come.
Okay, sir. Thank you, sir.
Thank you.
Thanks. So the chat box, one question raised by Professor Rangaraj.
Okay.
This Industry 4.0 will increase the unemployment in future.
Technology is, yeah, there is a question in the chat box. I hope lean manufacturing only provide comfortable to human. Industry 4.0 comfortable to system alone. See, basically, this is the one misconception we have about the Industry 4.0. So many people ask, many people tell that today the bank transfers are happening sitting at home through the mobile. So is it a Industry 4.0? No, it is not an Industry 4.0. It is a digital transformation. What has happened in the banking sector, or what has happened in the health sector, or what has happened in the different electronic, these cyber systems, what we see, that is a digital transformation. The industry specifically about the manufacturing or the processes or the process driven industries, there whatever, see, that is where the difference. Cyber physical system is different from cyber physical production system. Okay, so in cyber physical production, but the 5C architecture is the same. The connection level in a cyber physical system is maybe a barcode reader, or maybe some money counting machine, or some person's internet. This may be the connection at the banking sector. Whereas an industry sector, every manufacturing item, every manufacturing element of the machine has to be made enabled by the internet. So that is the need. That is the need of the requirement for the Industry 4.0. So Internet of Things. When we say Internet of Things, it is for the industrial things, for a power pack, for an hydraulic cylinder, for a pneumatic cylinder, for a ball screw, for a spindle, for the hose, for the machine. That is where we have to connect them with the internet, thereby they go to the next levels. So basically what happens is, yes, the digital revolutions has brought a lot of comfort to the human being. When it comes to the Industry 4.0 scenario, it is giving the comfort to the human being in an indirect way. It will increase, it will improve the profitability, competitiveness of the organization. It will improve the competitiveness, it will improve the profitability, then thereby it will improve the returns to the organization and to the employees and to the society. That is where it's an indirect way of improving the human life through Industry 4.0. And somebody is asking about the blockchain technology connected with the Industry 4.0. Yes, basically, all these, of course, blockchain is just emerging technologies now. So as I said, every new technology touched the human beings first. Okay, after it gets established in the day-to-day affairs and in the see, for example, you can see the QR codes. which came to the social media first. I mean, in the regular areas first. Then it came to it was, people felt that it is possible to use QR codes in the industry for trade tracking or the item tracking or the whatever way. So that comes there next, like the same way, blockchain is going to be very useful in the future. Maybe I think it's a very potential research topic in the future. I see only these two questions in the chat box.
Any other question, participants? Sir, one more question from my side.
Yeah.
Okay, so most of the faculty from mechanical engineering, now
Yeah.
the students are everyone moving towards the computer science and other branches. Mechanical
Correct.
admission all over India, last 2 years, we observed that this is decreasing, start decreasing.
Yes.
So what is the impact in the manufacturing industry because of this?
Yes. Yeah. This is something very, very relevant question. See, what is happening is like our core. I also see this development with lot of concern, because even in all very good colleges also, the mechanical branch is suffering, especially after this machine learning and this branch is introduced. Probably it has further hit the mechanical intake. So what I feel is that this is the high time that the mechanical branch needs a digital touch, or modernization of the branch itself. So probably, this has to be, it is like our mechanical branch is like a basic base of the pizza base. It needs a lot of toppings, to make it tastier and to make it more sellable. So basically, we need a lot of these topics to be covered. Mechatronics should be the first to be introduced as a core subject, and all these digitalization and the digital factors have to be incorporated in a very strong way into the mechanical stream. Then only probably this branch can see a revival. And because what is happening in mechanical industry now, as an industry, I see that I am with at least about 100 plus CNC machines, and the engineers we recruit are very less. Engineering graduates whom we recruit are at only the positions at the quality, or where some brain work is required, the design, engineering, and these areas we are recruiting engineers, whereas all other, the lower levels, are all filled with the ITIs. And now with the CNC machines being self-skilled, not even ITIs are required. We are taking people who are with basic, SSLC pass fail kind of people, because all the skills are transferred to the machine. Right. So people with 2 legs, 2 hands, and 2 eyes, ears, they are able to work in the industry. Okay, so that is the situation. So that being the scenario, the engineers are required at the brain level, at the brain work level, at the design and engineering and the quality levels. So we have to empower them, empower the branch with the latest in the digital area, latest in the technology area, latest in the mechatronics and the IT systems. So then only we can attract more talents and more people taking mechanical. We have to change the face of the mechanical engineering.
Yes, sir. You're right, sir.
Yeah.
Any questions from the participants?
Is artificial intelligence used in industry 4.0? Yes, artificial intelligence is one of the basic building blocks. There is something called ABC of industry 4.0. ABC of industry 4.0 means A for artificial intelligence, B for big data, C for cloud. So these are the three fundamental, primary elements of Industry 4.0. AI is a very, very fundamental, building block of Industry 4.0. Yes.
Hello, sir.
Yeah.
Now we will conclude, sir. Since the
Yeah.
second session, we have one more industry
Yeah.
person
Yeah.
to deliver his
Okay.
lecture. Nagaraj Jade
Yes,
is
sir.
waiting in the
Sure, sir.
meeting. Now, on behalf of Rajarashri College of Engineering and ACT sponsored ATAL Online FDP, so I would like to thank the speaker for the session, Mr. Ram Prakash Holla, the Managing Director, Distinct Property Solutions Bangalore, for his expert lecture on Industry 4.0. Thank you very much, sir. Thank you for spending your
Thank you
valuable
very
time with
much.
us.
Thank you very
Namaste,
much.
sir.
Thank you.
Nam-
Thank you, sir.
Namaste.
Namaste.
Thank
Thank you. Thank you. Bye. Bye.
Bye.
Yeah. So, you